reason that a shortcut works. Okay, so today we're going to jump into, it's actually section 2.2 in your book. We already covered 2.1, that was on the idea of the derivative in the first place, so that was part of the first unit. Differentiation is the process of finding a derivative. Yeah.
You run it really big so you can see it.
Can't get anything past you guys can.
Wait, so are you doing this for the rest of the year, or are you just trying it out?
I'm gonna, well, we're gonna see how it goes, and if people are actually finding it useful, I might just continue doing it. I don't know.
Was this your idea or school?
Well, I am part of the school,
Oh,
whether they want to admit it or not. All right. Basic differentiation rules. Rules in this case is a noun, although it could also be used as a verb, as in basic differentiation rules. But most people don't see it that way, so a noun is perfectly acceptable. First basic rule. The derivative of a constant function. If you graph a constant function, what's it look like? It does look like a line. Can you be more specific about what kind of line it looks like? Horizontal line. Good. Thank you for not saying straight line, because as we all know, all lines are straight. That's what makes them a line. Good. All right. So the derivative of a constant function, if you got your constant function, it might look something like this. So there's my x-axis, there's my y-axis. So there's a picture of our constant function. If I wanted to graph the derivative of it, this is y, or let's call this f. How about? If I wanted to graph its derivative, f prime, another word for derivative is slope. Okay. What's its slope right here?
0, 0.
Okay. How about right here?
0, 0.
Here's a tricky one. What's its slope right here? Zero, yes. Point being, the slope of a constant function is always 0. So if you were to graph a derivative of a constant function, what would that look like? It's always going to have a height of 0. It's going to be on the x-axis. So there's f prime. What if the horizontal line f were actually down here? Same thing, slope's always 0. It doesn't matter where the horizontal line is, the slope of any horizontal line, no matter where it is always 0. Therefore, the derivative of the constant function, no matter what that constant is always going to be 0. It's always going to look like the x-axis. Am I talking loud?
No.
Good.
Not loud enough.
I always talk this loud.
Yeah.
Wow. Okay. So that's the graphic way of looking at it. How about in the words, putting it in words? If f is constant, f prime of x equals 0. That's just the word version of this picture, right? If f is constant, f prime is 0.
Do you have to move that every time you move?
I think I might.
Do you want me to look your
Do you want to do it?
Yeah, I won't be here all next week.
At all next week?
So you're going.
This one's pretty huge. This one's pretty huge. This is a time saver, because really, this thing, we knew that even last week. If I had given you, if I said f of x equals 4, what's f prime at 10, you wouldn't have had to have gone through the whole limit definition of a derivative to tell me that the slope's going to be 0. Hopefully you could have common sense that out. I just use common sense as a verb, I know. This one's going to be huge, because this is going to save you from having to do limit definition of a derivative on a heck of a lot of problems. In fact, any polynomial function, and even some that aren't polynomials. This one's so huge that if you put it in front of the sun, the Earth would just become a black shadow and all life would cease to exist, except for cockroaches and math teachers. If f of x is x to some power. Let's see. I'm just nervous that that's not. No, that's there.
I'm supposed to check it, I didn't know he wanted me to check it.
I'm sorry, I'm kind of control freak. If f of x is x to some power, where n in this case is constant, so it's not like x to the x power, it's x to like the 5th power. N has to be like an actual number, not another variable. It's a variable, that's a whole other topic. Then f prime of x, the way you get the derivative is just simply, maybe even notice this, if you ever notice if you got the derivative of a parabola, what you'd get every time? Yeah, something to the 1st power, right? Yeah. And I think we did one to the 3rd power, and our derivative was the 2nd power. You kind of see what happens there? I mean, what happens to the power every single time? It drops by, every time you take the derivative, the power drops by 1. And in addition to that, this is a little harder to catch. Whatever was the power in the original function is going to become the coefficient in the derivative. So, putting all that together, if the power drops by 1 and the old power becomes the new coefficient, could you tell me what we're going to have here?
X to the n minus 1.
That's part of it. And also have an n out front. So what used to be the derivative, or what it used to be the exponent, is now going to be the coefficient. And then you'd have x to the n minus 1 power as your new exponent. So bring the exponent down as a coefficient and drop the power by 1.
So it won't be like illegal if we don't understand these to just do the original. Limit
It's a long way.
If you want to do that, you can. I'd buy another notebook.
Well, I know, like if we didn't, like then a problem if we zoned out, like it wouldn't be like.
Yeah, trust me, we're going to be doing these so much that it'd be like forgetting your name. I mean, it would almost be that bad. Yeah, that's fun.
You're not a
I forget that, but we're happy, so.
All right, for example, let's say g of x is, oh gosh, let's do 4x squared. So g prime of x, yeah, the 2 is going to come down out front. Well, there's also a 4 there, that's fine. So now instead of 4, we've got double it. We've got 8. And it's no longer x squared, it's x to the 1st, or just plain old x.
What's that definition of
He
a
has to That is. Wait, what?
Mine just got low.
Why?
Because he just showed us the shortcut we could have used in the test, and I wrote
I didn't even finish it. So
There, it's
and I
that
would
big.
have been done in like 2
On our
seconds.
paper, the long way, it's that big.
Yeah.
Why can't you show us that first?
That was my definition
Just,
of a
I
derivative.
trust
It's
you.
just shortcut.
For 1 over x.
Just gone.
What, 1 over x?
It's nice to know that my question.
4. She said 4 over x.
We could actually do that right now.